Welcome to the Continuing Education webinar. Today's topic is the human gut microbiome and its effects on obesity. My name is Joanna Johnson.
My name is Amy Standifer.
My name is Courtney Davis.
And I'm Lauren Oswald.
Our objectives today are to explain the microbiota influence and the different mechanisms that can affect the gut, the ratio of Bacteroidetes and Firmicutes and how they relate to obesity, and also how the microbiota metabolism affects that idea of energy harvest. Involving gut microbiota and its effects on energy homeostasis can give insight to the obesity epidemic. Firmicutes and Bacteroidetes are two of the bacteria that comprise 90% of our human gut microbiota. Jeff Gordon, Lay, and Turnbog gave the idea of energy harvest, which is microbiota allowing humans to extract calories from indigestible polysaccharides for energy. Turnbog took mice homozygous for a mutation in the leptin gene and OB, which means obese, siblings and lean siblings to compare the composition of their gut microbiota. Obese subjects have a higher ratio of Firmicutes to Bacteroidetes, while in lean individuals the opposite holds true.
Turnbog and Lay were the first to report that gut microbiota extracted energy from indigestible polysaccharides contributes to obesity. The bacteria, Bacteroidetes and Firmicutes, have genes that encode for enzymes involved in metabolism of indigestible polysaccharides. These enzymes break down the indigestible polysaccharides to monosaccharides and oligosaccharides. These are then fermented into short-chain fatty acids. These end products are propionate, acetate, and butyrate, which go on to carry out physiological functions in the body. Butyrate is the main energy supply for colonic epithelial cells. Propionate and acetate are used by the liver as a precursor for liponeogenesis and gluconeogenesis. Liponeogenesis is the process of creating fatty acids that synthesizes fatty acids to be utilized by various tissues. Gluconeogenesis is the process of creating glucose to be used by the central nervous system and other tissues. When the body is in a state of starvation, gluconeogenesis and liponeogenesis are vital to survival. However, when the body is fed, the excess glucose and fatty acids created from microbial energy extraction flow through metabolic processes to be stored as glycogen and fat. Experimenters also discovered that less energy in the feces of obese mice. This supports the theory of caloric extraction and energy harvest.
The gut microbiome adjusts to the type of diet and can change its ratio from high Firmicutes to Bacteroidetes to the lean ratio of higher Bacteroidetes to Firmicutes. A couple studies have proven this to be true. Mice were fed a Western diet that consisted of fats and carbohydrates. The remaining mice were fed a controlled carbohydrate diet. The mice that were fed the Western diet gained more weight than the mice on a controlled carbohydrate diet. A follow-up study was performed on mice that ate a Western diet from birth and then were weaned onto a lower-calorie diet. The mice lost weight and their microbiota changed to the favorable lean ratios. Another study involving humans and diets of children from Africa and Italy also illustrate how the body has adapted to energy harvest. The African children ate primarily a high-fiber diet of grains and plant foods, while the European children diet was high in fat. Breastfeeding children from both communities had similar microbiome profiles. After weaning, the microflora in these two populations diverged dramatically. The African children consumed less total calories, but their microflora had adapted to extract the most energy possible from their plant-based diet. The European children had a higher calorie intake and more microbes that were capable of harvesting energy from fats.
The findings of Bacteroidetes and Firmicutes research are helpful in the future of obesity and gut genomic work. Though there is no absolute relationship found, these studies are still relatively new, beginning in 2006. This gives hope to the future of obesity research and its epidemic itself. In the meantime, we would like to get other research on more human subjects, similar to the studies already done with the twins and children from different areas of the world, similar GI systems studied, like the pig, for example, and continue gut bacteria testing in relationships that they provide to obesity. We hope that you enjoyed this informational session on gut microbiome and its effects on obesity. Please fill out the short quiz afterwards to submit for 2 additional continuing education credits. Thank you.